Hello class, and welcome to lesson 1.8, transforming graphs using mapping. Mapping is a technique, ladies and gentlemen, where you're going to start with the parent function, apply the shifts that make a stretch or compression either vertically or horizontally. So I'll just back up here. If you look up here to this new formula down here, that's your parent function you're going to start plotting. So we'll do one graph of that. Then we're going to plot, the second step is to plot all the stretches and compressions and reflections either vertically or horizontally, and last we're going to do the translations that are either horizontal or vertical. Please be aware, ladies and gentlemen, I will always provide you with this formula and you will use it on several unit tests. So it's good to develop a good understanding of it right away so that you can improve on this for future units and evaluations. All right, let's get started, gang. All right, so today we're going to recall the formula we learned yesterday or last day, completed with all the letters. Remember we learned K not so recently. Let's just quickly remember what these mean. So A and K deal with stretch, compression, and reflection. You will notice that that's dealt with step 2 of our mapping sequence. We're going to apply the A and the K to the parent function first. Then, ladies and gentlemen, our last step is to apply this D and C, which are your translations. Those are your shifts either up or down, and that's in the third stage of our mapping process. One thing to note, ladies and gentlemen, is that when you're dealing with A and D, they deal with the horizontal axes or the effect or the movement of X, whereas A and C deal with the vertical movement on Y. What does that mean? When you look at this formula, ladies and gentlemen, down here, you will notice that when you add in the A and K, it applies to the X coordinate versus, so right here and here, whereas when you take a look, ladies and gentlemen, at the A and the C, it's applied to the Y coordinate of the vertex, okay? So think of these as ordered pairs. So we're going to plot ordered pairs of the parent function, which is down here in this chart. Then we're going to apply it to the stretch, compress, and reflection, which is stage 2. And then stage 3, we're going to add the translations left, right, up, or down into it. All right, let's take a look at an example. All right, so up above, ladies and gentlemen, example 1 right here, it says g at x has this equation. Notice you can't graph it as it is because it's got the function notation inside of it. That means we can apply any all these transformations to each parent function or a given parent function. We're not told specifically up top what parent function to use. It's not until we get to part A where it says to write the equation for it. All right. So what we need to take a look at is to write the equation f at x equals 1 at x. So that tells us our parent function is the reciprocal. So when we go to write our equation, ladies and gentlemen, g at x is going to equal 2, because that's A, but it goes on top, right, when you're dealing with the reciprocal function, okay, over K, which is negative 1/3, times x plus 1, all subtract 4. So now that it is now that it is a proper notation, no longer is the function notation, we can now graph this. Okay, what I mean by that, ladies and gentlemen, if you take this equation I'm giving an arrow to and you plug it into a graphing calculator, you will be able to graph it. If you try plugging that into a graphing calculator, you will get an error simply because it doesn't specify which parent function to use it to. All right, now let's go over how the heck do we deal with this mapping sequence, okay? The first thing I always do whenever I get a transformation to perform, I always take a look. What's my A, K, D, and C? So looking at my equation in A up here, I'm going to fill in this spot right here. So looking up there, ladies and gentlemen, you should recognize that A equals 2. You should recognize that K equals negative 1/3. You should recognize that D equals negative 1. Remember, it's the opposite because there's a positive in there. So how does the equation become positive from negative? It had to be multiplied by negative. And C is your number out at the end, which is negative 4. Okay, if you can do that, ladies and gentlemen, you're about 1/3 of the way there. The part that I find is the hardest in all honesty, is to just put these AKDCs into this formula. So at the top where you see the shaded part of your graph, this is what we're going to do. So just remember that this is going to be the first chart here, ladies and gentlemen, if you want to take a look at it. This is our parent function. So this is what we're going to do. We're going to apply that to f at x. Sorry, f at x, which is your parent function, which is 1 over x. Okay? So we're going to pick values for that. So in the past, ladies and gentlemen, we've gone 2, 1. Now we could do 0, but you know that when you have a reciprocal function that's an error because of the asymptotes. So let's just stick in 1/2 here, and then I'm going to go negative 1/2, and then I'm going to go negative 1 and negative 2. All right, the other two kind of shaded ones at the bottom here, we're going to leave these for the asymptotes. Simply because the asymptotes are easy way for you to graph reciprocals. So currently we know we've got an asymptote at y equals 0, and we've got an asymptote at x equals 0. Okay? Now if those are our x coordinates that we're picking, ladies and gentlemen, sorry, that's a negative 1/2 that we're picking, we got to sub it into our parent formula here to get our y values. Okay, so let's do that, and then we'll sub in our y values. So if you sub in, ladies and gentlemen, an x being 2, you're going to get f at x or y to be 1/2. Again, that's just your input and output. If you sub in x equals 1, you're going to get 1. If you sub in x equals 1/2, remember you got to invert and multiply, you end up with 2. Okay, negative 1/2, you sub in there, you're going to get negative 2. And then when you sub in negative 1, you're going to get negative 1, and when you sub in negative 2, you're going to get negative 1/2. Again, come see me if you need help with substitution. All right. Now we're going to, that's step 1. You can either do this where you graph that right away and then do stage 2. Excuse me. I just tend to do this chart first and use different colors. So I would suggest that when you're doing your homework or you're doing your unit test that you have a couple different colored pencil crayons. It just makes it look easier to see the 3 different stages on your map. So I'm going to choose blue for my parent function. Let's choose red for my horizontal and vertical shift. So what does that mean? I apologize, not horizontal. I'm doing my stretch compression. So this part right here. So all I do is take whatever x is, ladies and gentlemen, and I've got to divide it by k. So over on the side, if I take x and divide it by k, my k in this sense, ladies, is negative 1 over 3. Remember, I've got to invert and multiply. So what does that mean? It's going to be x times negative 3 over 1, right? Which is going to give you negative 3. So my ordered pair for the first, for my second stage of the mapping sequence, which is my first dealing with the stretch, compression, and reflection, is going to be negative 3 on the x. Okay? And then for the y, it says to take a and times it by y. So a in this case is 2, so it's going to be 2y. All right, once you've established that, ladies and gentlemen, you're just going to go back to the previous ordered pair you have. For example, right now I've got 2 here. I'm going to times it by negative 3, so I'm going to end up with negative 6. Okay, then I look at my y. Okay, and I've got 1/2, and I'm going to times it by 2, and that's going to be 1. So now I've developed a new ordered pair. Okay, so all that says is, hey, this is my ordered pair on my parent function, and when I apply the stretch and compression and reflections, it's gonna develop that ordered pair. All right, everybody good with that? Okay, so let's apply those to all the columns here. So again, 1 times negative 3 is going to give you negative 3. I'm just going to do the brackets and the commas ahead of time, just because that's how I set it up. It's up to you, because they're all ordered pairs, and I'm going to do my x's first and then my y's. Okay? So when I take negative 3 and times it by 1/2, I've got negative 3 over 2. Negative 3 times negative 1/2 makes that positive 3 over 2. Okay? Then I take negative 3 times negative 1, which is 3. And then I have negative 3 times negative 2, which is 6. All right? Now, ladies and gentlemen, when you do a stretch or compression or reflection, that does not change your asymptotes. So that keeps them the same. But they will change in our stage 3. Okay, so stay tuned for that. It'll change right here. Okay? All right, let's apply the y's. The y's are easy, guys. You just double your the parent function y coordinates. Okay, so instead of 1, you've got 2. Instead of 2, you got 4. Instead of negative 2, you got negative 4. Instead of negative 1, you got negative 2. Instead of negative a half, you've got negative 1. And that is, again, stage 2. So all we've done is applied the stretches, the compressions, and reflections in both the horizontal and vertical. All right, now we're going to go to stage 3. Okay, stage 3, I'll go for green, ladies and gentlemen. Okay, and this is applying the translations. So your up-down movement or left-right. Okay, so basically it's going to be the same image as the second column. However, it's just going to be shifted left and right. It's not going to be distorted or stretched because that's what happens from the step 1 to step 2. All right. So what we need to do is take what's existing. So we already have the x over k. And so in this case, we already have the negative 3x. Okay, everybody got that? So we're just building on the existing column. Okay, and it says we have to add d. So what we're going to do is go minus 1. So that's going to be our ordered pair for our final graph. And then taking a look at the y-coordinate, AY, which we already have is 2y, and then we're going to add c, and c is negative 4, so we're going to go minus 4. So ladies and gentlemen, instead of reinventing the wheel and going all the way from the start, I want you just to go from the previous column, and we've already taken care of the negative 3x. So all we have to do now is subtract another 1. Okay? So from the x column, if I put my brackets down first because it's easier that way, I'm going to just subtract 1 from each of my x columns. So it's going to be negative 7, negative 4. You could go negative 5 over 2 or negative 2.5 because we're going to graph it. It might be easier that way. So subtract a half, 2, and 5. So far, so good? Awesome. And again, don't go all the way from the start. Start again from your ordered pair in the last column. So for the y-coordinate, we're just going to take whatever your y is and we're going to subtract 4. So 1 subtract 4 is negative 3. 2 subtract 4 is negative 2, etc. So just subtract all the way down. And now we've got our stage 3 of the mapping sequence. Okay? What we want to make sure we realize, ladies and gentlemen, is when we do our translations, either our D's or our C's, that affects the asymptote because that shifts everything left, right, or up or down. So if we take a look at our y equals 0 asymptote, okay, that's affected by C because y equals C in this case. Okay, so what does that mean? Y equals negative 4. So we're going to shift our asymptote up. That'll be easier for us to graph. Likewise, when we take a look at our x asymptote, that's related to x equals d. So in this case, it's going to be x equals negative 1. So we're shifting both of our asymptotes in the stage 3. All right, let's graph it, ladies and gentlemen. Take a look what happens here. So again, I'm going to color code it the same. And I know it's going to take a second to transfer things over. I might have to shift up and down, but let's see what I can do here. So we're going to start with our parent function. So we've got 2 and 1/2. Okay, 1, 1, which is our key point, guys, for reciprocal functions. And then we've got a 1/2 and 2. Okay. And so, ladies and gentlemen, notice that, again, it approaches the asymptote. Because when you are in your parent function, ladies and gentlemen, remember you have an asymptote here at x equals 0, and you have an asymptote here at y equals 0. All right, you may wish to start with that to help you with your graphing. Now, we also have work to do in quadrant 3. So we take a look, and we got negative 1 and negative 1, negative 2, negative 1/2. And negative 1/2, negative 2. Okay? Everybody good with that? All right. That's stage 1. Okay? So that's really what we call f at x in the blue. All right. Stage 2, ladies and gentlemen, were applied stretch and compression. So let's just back up and say, hey, what has actually happened here? Okay? We are affecting, I'm just going to circle back up here. Oh, maybe my graph, there we go. We're affecting A, which tells us, hey, if A is 2, we've got a vertical stretch of 2. Okay? But we also have K being negative 1/3. The negative tells me it's reflected the y-axis. And 1/3, if you take a look at the factor, it's going to be also a horizontal stretch of 3. All right. So let's take a look at that. So instead of my key point 1, 1, that's where I'm going to start. So originally I was here 1, 1, right? I'm now taking that point and I'm at negative 3 and 2. Okay? So remember, guys, it's gone up twice. It's stretched up. So instead of being here, instead of being over here, right, it's been stretched up 1 and over 3, right? Because it's 3 times from where it should have been. Okay? And let's plot the other ones, because that's the key point to take a look. So we have negative 6 and 1. So 4, 5, 6, and 1. We have negative 3 over 2, which is negative 1.5 and 4. Negative 1.5 and 4. Okay. So that gives you a better perspective. And again, you approach the asymptotes that are still there. Okay. So the asymptotes are still the same. If you're color coding, you want to put them in for the stage 2. Okay. Asymptotes will not change from a stretch compression or a reflection. Okay. All right, let's do the other side now. So just remember, guys, this part of the graph got reflected the y-axis and then stretched and compressed. So those two are kind of like mirror images, if you want to think about it. They're not really mirror, sorry, they are the same image. It's a transformation image, but they're not mirror because this one the red one applies the stretch and the compression as well as the reflection. Okay, let's do the second part, ladies and gentlemen, which are the other pairs I just can't see here. So we've got a half and 2. Sorry, my fault. We've got 1.5 and negative 4. So 1.5 and negative 4. We have 3 and negative 2. And 6 and negative 1. Okay? So again, you're going to take, that's my key point for this side. I'm going to go over here and down. All right? Everybody okay with that? So just notice what's happened to the key point here. So my key point, and let's write it down here. So my key point that I started with my parent function, that's why I went to blue again, was 1, 1. Then it went to the ordered pair negative 3 and 2. Okay? If you break that down, ladies and gentlemen, it shows you the actual shift of A and D, A and K, so you could figure that out. Okay? So the shift between here, guys, is negative 3, but that if you put that in a factor, that's going to be a factor of negative 1 over 3. So that tells you your K. Likewise, when you take a look here, ladies and gentlemen, the Y, okay, it's got twice as big, so that tells you it's going to be 2, so that tells you A equals 2, because that talks about the vertical. Okay, whereas I'll back up here, this one's the horizontal. Okay, you'll get that later on. I'm just trying to get you to be able to develop from a graph the equation, because that will be coming later on too. All right, stage 3, ladies and gentlemen, the last one. It is just taking our red graph and either shifting it up or down or left or right. The easiest thing for me to graph to start with is our asymptotes. So I'm going to start at y equals negative 4. That's why color is important today, guys. Okay, and then I'm going to have x equaling -1. So my asymptotes now have shifted. Okay. All right, so let's plot these points and then I'll show you a potential shortcut if you'd like it. Okay, so the first point I'm looking at is -7, -3. So -4, 5, 6, 7, 1, 2, 3. And then I'm going to go -4, -2. Then I'm going to go -2.5 and 0. Okay, so that's going to give you your 3 points over here. Oopsie, gonna make that closer there. Okay, so notice it's very similar to this line. We've just shifted it down 4 and left 1. And that's the kind of key that I'll show you in a minute. Oh, actually, I'll show you right now. So if you take this point and you go left 1 and down 1, 2, 3, 4. Take this point, go left 1, down 1, 2, 3, 4. Take your points that you have existing and do the same translation. Each time you're going to get the required third step. Okay, let's do the last part, which is over here in the other quadrant. So we're looking at 1/2 and -8. So 1/2, there's 4, 6, 8. Okay, and then we've got 2 and -6. And then we've got 5 and -5. Okay. And again, ladies and gentlemen, you could take this point here and go left 1 and down 1, 2, 3, 4. Take this point here, go left 1 and down 1, 2, 3, 4 to get that. Okay? All right. As long as you color code them, ladies and gentlemen, I will see your steps and transformations. So I would appreciate if you color them so then I can see exactly the mapping sequence. So there, ladies and gentlemen, we have sketched all 3 graphs, and now all we need to do is state the domain and range of the function, of the final function, which is your stage 3. Okay? So just remember, if you're taking a look at just the parent function, for example, what's the restrictions on that, ladies and gentlemen? Okay? The domain is such that x belongs to a set of real numbers, or is set of real numbers such that x cannot be equal to 0 because of the asymptote, right? You guys good with that? And the range is such that y belongs to a set of real numbers in that y cannot be 0 also because it's an asymptote. That's the parent function, okay? Now if we take a look at our g at x, okay, which equals to, just write it out here, 1/3 x plus 1. Sorry, that's a squiggly mark on my smart board, does it for me. Okay, taking a look at that, ladies and gentlemen, we have to take a look at where our asymptotes have been affected. Okay, so if you remember, ladies and gentlemen, if you go up here, how our asymptotes get affected, it's right here. Okay, so the domain is where x belongs to a set of real numbers such that x cannot be equal to -1. And the range is y belongs to a set of real numbers such that y cannot be equal to -4. Okay? Just remember your restrictions for the reciprocal function is on your asymptotes. All right, let's take a look at a different aspect, ladies and gentlemen. You'll be trying some of these for homework, and hopefully you get a good grasp of it. But here we go. Try a different arrangement here, ladies and gentlemen. So it says for f at x equaling the absolute value of x, so it's telling us it's the absolute value parent function. State the transformations applied to obtain the graph of this. Okay, so remember last day when we talked about k, I always said make sure you factor out k. Here's an example where you need to factor out k. How can I tell when I need to factor it out? When there's not a bracket between the -3 and the x. Okay, the first thing I need to do before I do the factoring out is I need to take my transformation function because it's got f at x and I need to relate it to the absolute value. Then I will do my factoring. Okay, so the first thing I'm going to do is go g at x equals the absolute value of -3x plus 6. okay, because I'm applying the absolute value. Now I can graph it because I've specified what parent function I'm applying the transformations to. And then what I need to do is remember to factor out. So here is where you have to factor out k. Okay, so this is going to look like absolute value of -3 and take -2 out of the two terms, and you've got that. Okay, and then, ladies and gentlemen, all you do is base it on A, K, D, and C and tell me what each means. All right, so in this case, ladies and gentlemen, A equals what value? It's up front, out front here. Oh, for those who forgot the formula, I'll just write it out here. So it's A times F times K times X minus D plus C. Okay, so A is way out front. So what's out front? A equals 1. That means there's no stretch or compression or reflection that way. Okay, then we'll deal with K. So K is right here. So K equals -3. That tells us a couple things. One, it tells us that it's going to reflect the y-axis. Okay, and number 2, because it's 3, don't forget to put it in the factor, the 1 over absolute value of k. So you're going to have a horizontal compression by a factor of 1 over 3. Okay, remember the absolute value, so the negative disappears. The negative gets caught up in the reflection part. All right, the next thing we have to take a look at is what is D? D equals 2. So what does that tell us, ladies and gentlemen? We have a horizontal translation. Okay, 2 units right. Okay, and when we go to take a look at our C, C equals 0, which tells us, ladies and gentlemen, there's no translating up or down. Okay? All right, ladies and gentlemen. So for your homework today, I want you to take a look at the handout I gave you in class, or check my website, and the link will be there to the graphing using transformations of parent functions, okay? And that's going to be practicing that mapping sequence. Have a good day, ladies and gentlemen. Come and see me if you need any help. Goodbye.